Today we're going to take this Iron Man mask, which is a battery operated, makes the eyes light up, hang it on the wall. Beats me. I know it's part of a kit, but I got it at Goodwill. Anyway, I don't like the way the eyes light up. I think they're kind of broken now. I took the screws out in advance, which apparently was a bad idea, since it's broke the power wire. So there's the eyes. I'll kill some lights here so you can see it better. Still hard to see. Let's turn off the other light. Alright. Yeah, it's hard to tell on camera, but there's a hot spot right here in the center of the eyes, and then they fade out real bad in the corners. I think it kind of looks like crap. And I was going to modify this into the eyes are a nice even glow, and then make the mouth light up. Just turn the light back on here. A little bit better. So to do that, I also want to make it remote, so I don't have to keep walking over and press the little switch on the bottom. I'm going to use RGB rope light. It's 5 volts. This unit's 4.5. It's a USB rope light with a remote. And I'm going to stick it inside here and be able to control it from across the room. So maybe Iron Man has his white eyes, or his one day they want to be red. So as you can see here what they look like. The biggest issue is just for testing. We'll stick the lights inside. We'll turn off the lights. And the red is anytime you have a color that has a red frequency or a red LED lit, the mask lights up. So if I turn it to blue, you can see the mask doesn't light up. Or green, the mask doesn't light up. And that's because it has the blue frequency in it. But if I turn it to red or yellow, you can see the outside is yellow, but the mask is orange, red, pink. You can see we don't want that. The mask never glowed in the movies. And then of course we got white. And it has the options of like strobe and fade. Yeah. So, to solve that, what I'm going to try and do is, let's not blind you with the light, spray paint the inside of this black. Something that absorbs all light, but allows the eyes and the mouth to glow. So, let's get some light back on. Go. So besides the RGB lights, you can use 12 volt ones if you want. They're cheaper, but I have some 5 volt ones. We use a scrap piece of plastic. This is just clear, I think it was acrylic that I bought. And I'm going to take a rotary saw and cut out the mouth and then slide this in so it has the effect of fiber optic. So the light will shine through the edge, which is going to be really hard to see kind of there on the corner. So tools, you need a screwdriver. I took the screws out. Again, I shouldn't have done it in advance, so I wouldn't drop it. You'll need a rotary saw. I'm going to use a Dremel with a fiber blade. We're going to cut it out. Spray paint, black. This is double back tape on the back. If it doesn't work, hot glue to hold the lights in. Then I'm not going to need the switch, so I'm going to get rid of the switch, and then the power source, which will be either a 9-volt battery with a resistor or a USB power cord, will either be coming in the bottom where the switch is, or I'll stick it inside here. As the project moves along, we'll see what works the best, or maybe I'll do both. So it can run on a battery and run on a USB power. We'll see. Just see where we get to when we get to that point. First thing though is I'm going to unscrew the eyes so we can get this out for paint. They're itty bitty little Phillips. Them. These type of LEDs are okay for pinpoints. If you notice, it might be hard to see, there's a little white dot in the center. That's where the light comes from. Gives you more of a beam of light, whereas a standard LED, where it's more broad. That's why I don't like these, because it gives you the hot spot in the center of the eyes. So they do work, they are bright. I just don't like the fact they give you more of a pin light than they do a broad spectrum light or a flood. So first things first, we're going to get some tape. I'm going to tape off the outside of the mask. I'm going to tape up the eye holes, because if you don't tape up those little eye holes, what was the point? Because you'll spray paint the insides black. Insides. So, and I probably would recommend hot glue or super glue, Gorilla Glue, because even though this is a Marvel mask, it's made in China and it's pretty flimsy. They're hot staked where they melt the plastic over itself to pin it, and this pin had already broken. You can re-hot stake it with a soldering gun. I wouldn't recommend it. Just that will do you a super glue in the corner or hot glue. Fixed. So I'm gonna mask it, spray it. When it's ready, we'll bring it back in, show you it, then show you the process of cutting out the mouth. And of course, we're also going to have to cut out some of this black plastic for the eyes. I'm not going to take the stakes out, because these black inserts is actually what keeps this white insert in place. So we're just going to cut out so the black ring is left with the 4 plastic stakes on each one. It's not a big issue or a project, but it's just something to try to make it look a little bit better, more movie quality, with a little touch of, you know, one day he wants his eyes to be blue, next day he wants them to be red. Do a little modifications, as you might say. And, you know, hanging on the wall next to the arc reactors. So we'll return when this is painted and ready for cutting of the mouth and the inside of the eyes. Here we are in the Random Junk workshop. The mask, or the light, is all masked off. Got some cheap, quick color focus. It's gloss black, but flat is what I was looking for, but use what you use. That's the reason with a random junk channel. And I'm just going to slowly go over it, a couple of coats, because unfortunately the seams right in here are not airtight. So if you spray too hard, you can actually push the black paint around the gold into the red, which will smear in the mask. If we get a little bit, there's some ways to remove the paint without damaging the mask or light. So we'll see what happens. So I'm going to start with finish this coat here, let it dry, do another coat. I use this stuff called Quick Color. I get it at Home Depot. It's 99 cents a can. Comes in two colors, white and black. Both come in gloss and flat. So that's where I get it from, in case people were wondering. I use it all the time. It's really good for darkening stuff and painting metal, as an example, when you just need something to be black and durable. And it generally dries to the touch in 10 minutes. Today is 107, so it'll probably dry a little bit faster. So we'll be back when she's ready to be shown. Or excuse me, he will be ready to be shown. Iron Man. Just finished up the third coat. So this is 3 coats. As you can see, it's wet. It's really glossy. And it is definitely black. So I'm hoping that will absorb enough of the light to not allow the red frequency of light to show through. We're going to find out, of course. Let this dry for an hour before I peel the paper. That way I don't get any fingerprints on the inside. And of course then take those fingerprints and transfer them to the outside. So, but that's what it looks like. Nice and dark. Just give a little light on the subject. See, it's nice and shiny. It's all black. So, alright. Wait for the next step. Okay, here's the mask. You still have a little bit of bleed through on the corner, on the edge, but it's all black on the inside. Get the light on here. Turn this light off. So what it's picking up is right here. It's painted, but it's apparently the paint isn't as thick right on this seam, which is this piece here. The paint is 3 coats, and it's nice, thick, and black. It's glossy. I said I normally would use flat, but grabbed the wrong can, which is fine. None of the paint came through any of the seams, which is good. So that means there's no touch-up that needs to be done. So it makes it a little bit easier. Now the next stage is you can use a rotary saw, so we can cut the eyes out, as well as start cutting the mouth for this part. And then on this, we're just going to remove the wires and adhere this light. Probably put a strip. Could just wrap this inside, which I'm not going to do. It's just a waste of lights. If you look at the face, if I put a strip of lights right around the battery area, that would take care of the eyes. And if I do a strip of lights right above the mounting points, that should take care of the mouth. Also, with less light in here, meaning not wrapping the whole back, draws less power, because this whole roll at its highest point draws 1.1 amps. We only cut off part of it. It's going to draw less power, also going to have less bleed through. So next step is to start cutting. And then we'll go on to trimming the plastic for the mouth. And then we'll work on the back. So let's get some tools. I'll show you how I start doing it, and then I'll probably just stop the video till I'm done, because it probably won't be very interesting watching me sit there with a rotary saw or a Dremel tool, and it's also going to be really loud on the microphone. So I'll be back in a moment. Alright, I have the Dremel. I use an extension flex head. I have two different types of wheels, small fiber and large fiber, to try. If your wheel is broken like this, don't attempt to use it. I know it sounds common sense-ish, but I've seen people try. This was a brand new wheel that chipped on a project that I was working on prior. It was on the machine for maybe 20 seconds when it got snagged and took a chunk out of it. Even though the wheel is nice and thick and only has a few revolutions on it, it's garbage. That's why when you buy them, they usually come in tubes of 20 or 30s because they're brittle. So I'm going to fire this up and get this started, and then we'll be back when it's pretty much done and we have an idea of what's going on. So I'm going to fire up the tool, and if you have headphones, it might be a little loud. Alright, I'm probably going to change to the bigger wheel because without going at an angle, it's not going through all the plastic. But you get an idea what's going on. So just carefully do this. Watch your fingers, watch your face for debris, especially if one of these wheels explodes. They're not as dangerous as like a grinding wheel on a 4.5-inch grinder. They can still screw you up pretty good. But we're going to basically sit here and just cut this away, and then when I'm done, I'll show you how I'm going to use a little attachment with a sanding disc to smooth it out if it's too rough. A lot of times when you cut plastic, if you do it right and you don't go too aggressively, this surface will actually smooth out your cut, and you don't have to do much sanding. Also depends on your plastic. If your plastic's really poor quality, sometimes it won't. So we're going to continue. Look back when we're at the next stage. Okay, we did the basic cuts with the big wheel. That way I can keep the blade parallel to the project. You can see there are some burrs in here, and if you let the plastic cool, because it gets hot from the motion, you can chip a lot of the burrs out with just breaking them off with your finger, or using a pick or a knife or a small screwdriver, something to get in there. And the pieces will just come out. Now, to get to the corners, to make the corners nice and clean, I'm using a very small carbide bit. It's really small. To go in here and clean up the corners and make them all connect, and then square up the edges of the jaw. Because when you're cutting with a circle, it leaves a curved piece inside to follow the curve of the circle. So I'm going to use the carbide bit to clean it up. You can use a diamond bit. Heck, you can even use one of the really small stones. I like the little carbide bits. They work pretty good. You can grab material and drag it, which is the only part I don't like about them. So it can, if you come up too high, it can grab and then you damage your project. That's why when I was cutting the wheel, I used two hands to stabilize it and help put pressure in case it tries to grab. So that's all the pieces of plastic. But anyway, so next step is to clean it all up and then cut out some slivers of this plastic. Probably just use the rotary tool and just slice off some edges, measure it, and then just force them in there. Also clean off the plastic protecting coating they put on here. So again, because of the noise, I'll show you how I start it, and then I'll stop it until I'm done. It might be hard to see, but now the jawline, see here, has got a, might be able to see it. There's a curve of plastic. Now the jawline's more square. So I'm going to go through, square up all the points, and then I'll probably get a small sanding disc and smooth it out, and then we'll do the plastic, clear plastic inserts. So I'll be back in a few. Okay, the mouth is cut out, and this is a rotary sanding disc. It's 60 grit. I'm not using it for spinning on the rotary tool. I'm just using it because it allows it, it's got a metal back that allows me to also hold it on the shank and then go through and start taking off the fine burrs. Make sure after you finish going through the track with your whatever you use that the plastic's cooled down. The burrs will come off easier when the plastic's not hot. The little bit, I don't know if you can see it, it's got some gummed up stuff from the plastic. The teeth are still good, it's just the shank, that plastic stick to it. And if you do make a mistake, you know, if you watch the Iron Man films, you know that his suit's got beat up, so you can always say it's a battle worn. Because I did have the tool walk. There's a small spot right here where the tool grabbed the corner and came out, which is what I told you can happen. And I didn't have two hands on the tool like I normally do. That was my mistake. But it's fine. Sometimes imperfections make things look better. You can also see that the jaw has some flex now. When we put the plastic in, that'll make it a little easier to get the plastic in, and then we'll put some glue on the back. You can see some of the tear out or tear through right in there. It might be hard to see. There's a stabilizer bar. We're going to just scrape that off with a fingers or a screwdriver. Once I'm done sanding, I have this in 60, 80, 100, all the way down to like 300 grit. I'm just going to get it rough enough that it's smooth for the plastic to slide in. I'm not going to make it pristine. But what I want to do is get off any of the high spots and burrs from the actual carbide bit and the rotary cutting blade. And then if you have any burrs in the corners, a pick, ice pick, a regular pick, small screwdriver, anything like that to get it out. There we go. That's how I was cleaning the track after I was on the carbide bit, because it leaves a lot of burrs, as I just grabbed a little pick to clean the track out with. Right now I'm just cleaning out the corners of the jawline, and then knocking out anything I just knocked in. Go. So. And the reason you don't want to cut this before you paint, if you decide to do something like this, is the spray paint will come out of the mouth and the whole front of the face around here would be, you know, black or whatever dark color you choose, if you even choose to do something like this. So we're gonna also, we need to cut the eyes out, which we'll do that in a few. Just gonna scrape some of the burrs off the back so they don't get in my way when we slide the plastic in. There is his opening and closing kind of mouth. Get some of the dust out. So the plastic, I don't know how thick it is, probably 1/8 of an inch, if that. It's going to be a tight fit. It should be a close fit all the way around. If not, I'll sand the sides down and make it thinner. But need to measure different pieces. So it'll be 5 pieces, 1, 2, 3, 4, 5, and this plastic does flex to follow the curve. So I'm going to try and use the non-cut edges for the part that sits out. So I'll be slicing it here and here for the edges to be here, here, and around, you know, to make the smiley face. So to do that, I'll either use another one of these fiber wheels, which they generate a lot of heat and create a lot of burr. My other option, which I've done before, is using the saw. So, creates a lot of sawdust, but doesn't create as much heat, and it doesn't do the big lumpy burr along the sides. So, I'm going to try the saw first, just to see how it does. And if the saw is too violent or grabs the plastic too violently, then I will go to the fiber wheels. I'll be doing it off camera because I need to use the vise and it's out of the camera's view. Because I'm going to try and clamp this. So, anyway, we're going to take some measurements, ruler, tape measure, eyeball it if you want. Heck, you could even, you know, do one of these and rotate it and put a mark. But I think what I'm going to do first is just cut off the ends, probably 1/4 inch, so I have 2 pieces, and then I'll start marking the pieces after I've cut the squared sides off. Alright, we're back. Little strips. Basically what I ended up doing was, once I started cleaning it up, the bottom jaw was only held in with a small burr, so I took the burr and I removed it, and the whole bottom jaw fell out. So you might have the same thing if you try and do this mask. So once the jaw fell out, I decided to quickly cut a few small pieces and wedge the jaw in and put a dab of Gorilla Glue to hold it, which apparently I put too much since it dripped. So anyhow, I took the strips. This is the smooth side. And then I sand. You can use regular sandpaper, you don't have to use a wheel. And I sanded the sides so the sides would be opaque and scuffed up. I left the smooth, flat side, the edge of the plastic, non-scuffed. The back side's already scuffed from the saw. And this worked the best, the teeth one. Since every time I moved it, the jaw kept falling out, I just took the plastic, put it up against the edge, marked it, and cut it. So this one has to be curved, and it does have flex, I'm actually going to heat it up a little bit so it doesn't try and push open. Now it's pliable. So get the curve this way, and then we'll curve it this way since the mask is curved in two directions. Might use pliers for this. It's set at 170 degrees centigrade, so it's nice and hot. If you don't have a heat pen, you can use a heat gun or a hair dryer or really hot water. You can soak your strips in hot water. I have heard of people putting it in the stove or microwave. Just got to be careful because you don't want to screw up either one of those two things with the off-gassing. Needs a little bit more. Ooh, that's getting a little too hot. And if I break it, I got another piece. But we're going to try not to break it. Almost. You probably have about 30 seconds of work time before it gets to the point where you can't flex it again. Yeah, not liking it. I'm going to use a pair of pliers because she's getting a little toasty. Just keep moving the heat back and forth. Don't heat one spot because you'll bubble the plastic or acrylic. Again, this is a thin sheet of what I thought was acrylic. It actually turns out that it's a thin sheet of Lexan. As I checked my stock, thought it'd be so difficult to make a frown. There we go. That's a lot better. It's not perfect, but it's a lot closer. So yeah, the process isn't the greatest. you all have a better way, let me know. Some people might think it's stupid just to do this project. I disagree, but because the principles that you might have or use can be used on other things, especially if you have miniature towns or you do cosplay. You can use some of the same principles. I do similar for my job, but it's on a bigger scale because I usually do props for television and movies. So it's nothing this small. Yeah. And when this is hanging on a wall, small discrepancies you aren't going to notice unless you're like staring directly at it, you know, a couple inches from it. What I'm going to do is I'm going to glue it from the back, but I want to put a drop in each corner on the front. One, it'll fill in the small gap, and two, it'll hold it so I can flip it over once the corner dries. So it doesn't fall out. I just need to reposition it before it hardens. There we go. I don't feel like gluing my fingers together. When you get in a bottle like this, it doesn't set as fast. You have to let it sit, which some people don't care, some people do. But it's got to sit for a little bit to harden before I can flip it over. And what I'll do is I'm going to run a bead across the piece of Lexan to solidify it to the inside of the mask. And then where the points are right here, if they're still jagged, I'll probably just use a small piece of sandpaper to sand the points down. So this now has to sit for a while because I think this has an actual set time of 2 hours. It's not the fast stuff. I get the slower stuff because I find it bonds better once it hardens. So I'm going to let it sit. Then when it's hard, flip it over, run a bead across the inside, and let it harden. And then she'll be good. At least this part will be. Then we'll start cutting out the backs of the eyes and do the light strips. So probably end up doing that while this hardens for the next couple hours. Since I'm breaking the light strips up, we're going to have to solder the two together. And it's a 4-wire. It's RGB. You got the red, the green, the blue, and the, I believe it's ground on this one. Some are hot and the returns are ground. Yep. So the R, G, and B are hot, and then the common wire is the ground. If you've ever used strips like this, you're supposed to cut them on the copper pads, which is on this one it's every LED. Sometimes it's 3 LEDs. So make sure I get good coverage of the mouth and the eyes. Have it go almost the entire width of the base, but I do need to ensure I have enough for this to plug back in. You can always cut it and just solder wires directly to it. A strip like so, and a strip like so, and that should give me enough light to illuminate the mouth and the eyes. Take a razor knife, score right behind the copper, just the plastic, don't cut all the way through, that would ruin your strip. And then I slowly peel the clear gel coating back from the actual circuitry to that cut line, which I didn't cut deep enough yet. Peel it. There we go. I normally don't use pliers for this because I need an edge to grab this silica or whatever it is that they use for a coating. And I find that angle cutters or wire cutters, the edge will grab that score line and expose the copper pads. Also, you can use it to trim if it's at an angle, so it's more square. When you do solder these together, it's your first time, make sure you solder the green to green, blue to blue, red to red, and the common to common. You do not want to reverse them. You will damage the little chips that are on here. There we go. Alright, copper pads are separated. I'm going to go grab some 4-wire so I can solder them across. They make 4-wire LED wire. I do have some. And then we're going to solder and measure how much wire we need to go from top to bottom and not interfere with the edge of the mask or the wall decoration, whatever you want to call it. I just refer to it as a mask. So, once this is on, I'll see how much power it draws, amperage wise, and we'll go and see if we can make it run off of a battery versus running off of a USB port. Because you may not have an extension long enough to plug this in to a wall, as an example, if it's in a display. I have a lot of items that don't have the ability to be plugged in, so I just run them off the battery. Alright, grab some wire, get this soldered up, taped on, see how it works. The mouth is hardened, and while it was hardening, I went ahead and stuck the lights on. It's pretty basic. You saw where I cut the two strips. They're taped down since they're double back tape. 4 wire runs across from one to the other, and then here's a little control module, and I have it actually wired to a 9-volt battery. The 5-volt controller is a 5 to 24-volt controller, and basically hooked in a 9-volt battery, since of course 9 volts between 5 and 24 volts. So if it's a 5-volt only, then you'll have to use a resistor off the battery. Because the power supply can handle up to 24 volts DC, no resistor was required. It's just hot wired right in, just like the original 4.5-volt battery pack. What I did have to do was remove the innards of the battery pack, the springs and the plates that the batteries rest against, and then I drilled out the, cut out the plastic spacers for the 3 AA's. So, and then looped it through. This knot here is the strain relief, so you can pull the battery out, you don't pull the wires. Have the wires running on the outside of the peg. You can hot glue them if you want, but they tuck inside the mask and you don't have to worry about any tension on them. It's a pretty basic setup. As you see, the wires here are red, green, blue, black. You just match them up to red, green, blue, and black, which is the common. I said earlier it was a negative switch. Or excuse me, the black was negative. It's actually hot. The lights are all negative. I had it backwards. But this controller, 5 to 24 volts. One thing I might do to it is cut this heat shrink and relocate the sensor. I'm going to see how it works through the plastic. If it's really hit or miss, I'll relocate the sensor and either stick it out the bottom by the switch, or maybe stick it in this chin, since the chin has this nice notch, somewhere where the IR can be picked up. Now, I did cut out one eye. As you can see, the big white oval. And what I'm using for that is this. It's not cleaned up. I just cut it to see how it worked. But rotary saw, again, it's a Dremel tool, with a saw blade. Fired up. Carefully go around the edges, and then I just use a pair of pliers to pull out the eyepiece, because the plastic re-adheres. Sometimes it gets stuck. There we go. And then there's the eyepiece. Now you can see two. Need to clean this up. A lot of this is the burr material, which when the plastic cools you can just take off with your fingers. There's lots of it. So what I'm going to do is, it's not completely cleaned up. A lot of the burrs are out, but it's a basic idea. get the gunk out of the eye. Let's see what it actually looks like, because final cleanup can always be done after, since it's pretty basic information. Put the back on. It's on all the way. Clear some of this out. Let's get some lights off. Controller. Flip the on switch. There we go. Much nicer. And green, blue, strobe, yellow, purple, red. So the eyes now have an even glow, which hopefully shows up on the actual computer monitors when you watch it, versus the hot spots in the center. The mouth now has a nice glow. If you look closely, you will see where the sanding process gouged up a little bit on the mouth here. It's just fine. It's not like I'm making these for production or anything. It's just for my wall. The eye sockets will get cleaned up. Runs on a 9-volt battery. At its highest power consumption, it pulls approximately 0.25 amps, or a quarter of an amp, which is pretty good. So that means it should last for a really long time on a 9-volt battery. As long as I point the controller to the left side of the head, and that's where the IR sensor is, the left side looking at it, be the right side if it was actually a mask, it does pass through. If I start having problems with it, all you do is cut off that heat shrink. You can either desolder and resolder the wires, or just cut them and connect in the middle, and I'll probably run it down to his chin, like I was telling you, right in this little divot. I thought about doing it here, but it's more obvious here, although it would be easier because the plastic flexes. You don't have to drill a hole, but I would just drill a hole and then hot glue the IR sensor to the underside, inside the mask, so, or head. But it does work. It's not probably the best tutorial I've done, because it would take hours to show it, especially with the delays and letting the glue harden in the paint and then cutting everything to fit, especially cutting this out and then cutting out the clear plastic to put inside his mouth. But I now have a custom lit Iron Man mask that I can put with my different Mark series arc reactors. It's been a long day, and now I can change the colors depending on what I want, or what I believe his mood would be. I really do like the red. It's not bad either, but strobe light. And the blue looks pretty cool too. So, but hopefully you got something out of it. So it's not the best tutorial, but it gives you some basic principles on how to cut out plastic and use it as a fiber optic, instead of using EL wire, which was recommended by somebody in the past. EL wire is 12 volts generally only, and it's neon and it has a hum, and I don't like the hum. Plus 5 volt, 12 volt light strips are a dime a dozen, and not too hard to find. This was one kit I got off of eBay a long time ago. Some generic no-name company, but other projects I've done, I've used them from Monster, and there was another company, a really big electronics company, I just forgot the name, but you get the idea. So even though the mask glows a little bit around the edges, I'm not too concerned. I actually think it kind of looks neat, having that dull glow, especially on the seams where the gold inlay is. So anyhow, this is it. Tony Stark's Iron Man mask with modified lighting. So